Okay, this is question 10.2 of this 2020 SUP exam. And let's just get started. Okay, here, the last question we have to do. They want us to prove that CD squared equals CE over BD. But whenever you see a thing like this, they're actually making proportions out of the sides. It actually comes from the fractions. And in the last question, we just we just figured out that triangle ECD is similar to triangle BDC. So that means you can make these fractions. Look, you can go EC goes with CB or BC, and CD over BD will equal ED over CD. Just match up the letters and make fractions, because if two triangles are similar, their sides are proportional and you can make fractions like this. Now look at this CD squared, CE and BD, that's these letters. So just write them down. And all you have to do is cross multiply. You get CD squared equals BD times ED. Well, that's not quite right. We don't have ED. We don't have ED. We've got CE. We don't have ED. We want CE. Hey, but in the last question before, we showed that these two sides were the same because of tangents from the same point. So because ED equals CE, we can just put in CE and then we get our answer. So there's the first question proved. Okay, let's try the next one. In the next question, they've got these fractions, CF squared over EF squared, BD over DE. So either it's similar triangles, or maybe we can use the idea of proportionality. There's more than one way to do this question, I think, but if you found it pretty challenging, so did I. But I did do this the first way, and then I forgot about the link from using the last question. But let's just get started. You can try it here. You can notice that C2 and D2, we did in the last questions equals X. These two angles are equal. Hey, that makes these two lines parallel. And if we have parallel lines cutting across this big triangle here, we can use the proportionality theorem. So BD is proportional to CE because the alternate angles is parallel to CE because the alternate angles are equal. Well, now we can make fractions. We can go FE over ED equals FC over BC. The sides match up because of the proportionality theorem, because BD is parallel to CE. Well, we look up here. Wouldn't it be nice if we had FC on the top? Well, we do, FC on the top. We'd like FE on the bottom. Well, you can just divide by FE both sides, and you'd have that. Well, it says, we would like the EF. We want the CF on top, the EF on the bottom. So I guess we're going to have to send the CB to the top, multiply both sides by CB. So then if we square it, we'll get CF squared over EF squared. So this FC, which is CF, if we square it, we'd have that. So we know it equals CB squared over DE squared. This is exactly how far I got. And then I forgot. I forgot this last thing that we did where CD squared equals CE times BD. So this CB squared, CB is the same as CD. So CB squared is really CD squared. And I can replace it with CE and BD. But hey, there's something else here. Yeah, that's it. The CE is really equal. The CE is equal to DE. We've done that before too. So I can replace it CEBD, but I can replace that with DE because they're equal. So that's that kind of game of substituting things because they're equal. I actually probably should have said that last substitution I made. I put in CEBD and then I substitute in DE. And now the DE cancels, and look, I've got BD over DE. This came from the memo. They left one little substitution. I should have said this last thing. If CE turned into DE, well, it can because we know those sides are equal. That's a pretty tricky question. Okay, and that's it for this paper two sub exam. That's all, folks.